In the depths of space, where darkness reigns and the fabric of reality seems to tear at the seams, there lies a mystery so profound that it has baffled scientists and ignited the imaginations of storytellers for decades. Imagine a force so powerful that it swallows entire stars, so mysterious that its true nature defies even the boldest predictions of modern physics. Tonight, we journey into this cosmic enigma to ask a riveting question. Could black holes be not merely destructive vacuum cleaners of the universe, but rather secret portals, gateways to alternate realms and parallel universes beyond our wildest dreams? Our adventure begins on the precipice of known science and flirts with the edges of speculative theory. As we hover at the boundary between observation and imagination, an unsettling thrill pulses through the cosmic darkness. There is an eerie allure to the image of a swirling vortex, a cosmic drain that might be more than a celestial death trap. What if, hidden within the tumultuous chaos of gravitational collapse, lies a door to an entirely different universe? Picture a traveler hurtling through space-time, approaching a black hole with trepidation, drawn by both scientific curiosity and an almost magnetic, inexplicable allure. The closer the traveler gets, the more the laws of physics start to blur like the smear of ink on a rain-soaked page. What awaits on the other side? Is there a world filled with wonders unimaginable, or a realm where time and existence itself are warped beyond recognition? In this documentary, we will take you on an immersive journey that oscillates between hard scientific inquiry and the tantalizing lure of cosmic myth. In the coming minutes, we will unravel the history and science behind black holes, analyze the theories that might position them as inter-universal portals, and delve into cutting-edge research and expert insights that stretch the limits of our understanding. Fasten your seatbelts as we plunge into the heart of darkness, where every discovery only deepens the mystery. Before we embark further, let's recap what we are about to uncover. Background science. We will explore the origins of black hole theory, examine how these celestial titans came to be understood through Einstein's theory of relativity, and uncover the complex interplay between gravity and quantum mechanics that defines their existence. Expert insights. Thought-provoking interviews with leading astrophysicists and cosmologists will shed light on recent breakthroughs and the tantalizing possibility that these cosmic powerhouses might be gateways to other universes. Speculative analysis. Merging science with speculative theory, we will dive into advanced models such as wormholes and multidimensional space, exploring how black holes might serve as passageways into alternate realities. Conclusion. We will conclude our journey by summarizing the provocative insights and open questions, inviting you to contemplate your own theories while leaving you with an unforgettable, lingering sense of cosmic wonder. Stay with us as we venture into a realm where scientific fact meets mind-bending possibility. A realm where black holes might not be just the end, but a new beginning. The darkness beckons, and it whispers secrets older than time itself. As our journey into this cosmic abyss begins, feel the weight of the universe pressing in, the silence of space laden with suspense, and the thrill of discovery igniting every fiber of your being. We are about to pull back the veil on one of the universe's most enigmatic phenomena. Let us now embark on this journey into the unknown. This is not just a story of cosmic destruction, but a tale of potential rebirth, of unseen worlds colliding, and of mysteries that could redefine our very notion of existence. With every heartbeat echoing into the expansive void of space, we now transition to the next phase of our exploration. A deep dive into the science that underpins these astronomical mysteries. To understand how black holes might be portals to other universes, we must first build a foundation in the science that governs them. black holes are not some abstract figment of science fiction. They are real, observable phenomena predicted by Albert Einstein's theory of general relativity nearly a century ago. Their existence has been confirmed through observations ranging from the movement of stars orbiting the invisible mass at the center of our galaxy to the recent imaging of a black hole's event horizon by the Event Horizon Telescope. At their core, black holes represent regions where gravity has collapsed matter into an infinitely dense point called a singularity. Surrounding this singularity is the event horizon, the boundary beyond which nothing, not even light, can escape the gravitational pull of the black hole. This defining characteristic has led to an enduring sense of unease and mystery. How could an object so devastatingly powerful also be a doorway to realms unknown? To take a closer look, we must understand the life cycle of stars. In our universe, massive stars burn through their nuclear fuel at unimaginable rates. When these giants reach the end of their lives, they often explode as supernovae. In some instances, the implosion of a supernova is so complete that the remaining core collapses under its own gravity, forming a black hole. These cosmic titans, though born from the violent death of stars, become the stage for the most exquisite dance of physics. The foundation of our scientific understanding comes from Einstein's revolutionary insight into gravity. General relativity describes how massive objects warp space and time, creating the illusion of gravity. In the vicinity of a black hole, this warping intensifies dramatically. The more massive the black hole, the more severe the distortion of space-time becomes. This alteration in the cosmic fabric is not just a theoretical fancy. It tells us how the universe can bend, twist, and even fracture into complexities that defy our conventional understanding. In addition to general relativity, the field of quantum mechanics adds another layer of nuance to the black hole puzzle. Quantum mechanics deals with the behavior of particles on the smallest scales and introduces a probabilistic flavor to reality. One of the key quandaries is how quantum theory can be reconciled with gravity, especially in the extreme environments found near black holes. Concepts like Hawking radiation, a form of energy gradually emitted by black holes, further complicate our picture by suggesting that black holes might eventually evaporate over immense timescales. These scientific paradigms pave the way for some of the most innovative and daring theories in modern physics. Some researchers speculate that a black hole's singularity might not represent a zero-dimensional point after all, but rather a doorway, a wormhole in space-time. A wormhole is a hypothetical tunnel connecting two separate points in space-time, possibly across different universes. While this notion pushes the boundaries of conventional physics, it remains a tantalizing idea that could offer an explanation for some of the universe's greatest mysteries. The mathematics behind black holes and wormholes are as intricate as the theories themselves. For instance, solutions to Einstein's field equations, such as the Kerr metric for rotating bodies, hint at the possibility of ring singularities, where the fabric of space-time becomes twisted in such a way that it might connect to another region of the cosmos. While the observable universe continues to confirm the predictive power of these equations, many of the deeper implications remain shrouded in theoretical fog. Modern science has also uncovered that the nature of black holes is not static. Studies have shown that black holes can grow by accreting matter, devouring gas, dust, and even stars, further intensifying their gravitational grip. This process of growth and interaction with surrounding matter gives rise to phenomena such as relativistic jets, bursts of energy that emanate from the poles of some black holes and extend far into intergalactic space. These cosmic behemoths, in their unyielding darkness, are paradoxically some of the most luminous markers in the night sky when engulfed by swirling disks of infalling matter. Moreover, the interplay between black holes and the quantum world remains one of the most exciting arenas of research. The concept of quantum entanglement, the mysterious connection between particles regardless of distance, has even led some scientists to propose theories such as the ER equals EPR conjecture, which suggests that entangled particles could be linked by tiny wormholes. This idea hints at a deep underlying connection between quantum theory and gravitational phenomena, providing yet another angle from which to view the possibility that black holes serve as cosmic portals. Amid all these intricate details, one truth remains universally accepted. Black holes force us to rethink the very fabric of reality. Their study pushes us to question our understanding of time, space, and the limits of physical law. Could these enigmas be the keys to unlocking pathways into parallel universes or entirely different dimensions of existence? The scientific community has only begun to scratch the surface of these possibilities, and the theories that connect the microscopic world of quantum physics with the macroscopic structures of the cosmos provide fertile ground for speculation. As we review the landmark discoveries and essential scientific principles that frame our understanding of black holes, the questions multiply. What is the true nature of the singularity? How might the principles of quantum mechanics transform our conception of space and time in the presence of such extreme conditions? And most provocatively of all, could black holes in their mysterious depths harbor passages that lead to realms beyond our observable universe? To answer these queries, we must consider both the observed phenomena and the mathematical models that describe them. Through meticulous study of gravitational waves, ripples in space-time that arise from violent cosmic collisions, researchers are beginning to piece together the dynamic behavior of black holes. These insights are not only compelling evidence for the existence of these enigmatic objects, but also a doorway into a deeper understanding of the laws governing our universe. In laboratories and observatories across the globe, experiments are continually designed to probe these frontiers of physics. Sophisticated instruments such as the Laser Interferometer, Gravitational Wave Observatory, LIGO, and its international counterparts have detected the faint whispers of colliding black holes, reinforcing the notion that these mysterious bodies are fundamental to the cosmic tapestry. Each detection brings us a step closer to comprehending the interplay between gravity and quantum mechanics. In this segment, we have traversed the foundational landscape of black hole science, a journey from the violent deaths of stars and the birth of singularities, through the elegant formulations of general relativity and quantum mechanics, to the tantalizing hints of wormholes and cosmic bridges. It is within this complex mosaic of discovery that the idea of black holes as portals begins to take shape, inviting us to expand our horizons and explore the possibility of new, uncharted universes. As the night deepens and the mysteries of the cosmos unfold, keep your mind open to the possibility that the universe is far more wondrous and bizarre than we can ever imagine. The dark secrets of black holes might not only reveal how these gravitational titans function, but could also uncover pathways to realms that defy our conventional notions of time and space. With our scientific foundations firmly in place, we now turn our attention to what the world's foremost experts have to say about these fascinating enigmas. The mystery of black holes has captivated scientists for generations, driving them to develop sophisticated models and theories that stretch our understanding of physics to its very limits. In this segment, we bring you first-hand insights from astrophysicists, cosmologists, and theoreticians who have devoted their careers to unraveling the secrets hidden within these cosmic abysses. Dr. Amelia Hawthorne, a renowned astrophysicist whose work on gravitational dynamics has made waves in the scientific community, explains, "Black holes represent one of the most extreme environments in the universe. Not only do they challenge our understanding of gravity and quantum mechanics, but they also prompt us to ask provocative questions about the limits of reality itself. When we consider the possibility of a wormhole, a tunnel that connects distant points in space-time, it forces us to confront the radical idea that our universe might not be the ultimate reality. There may be, lurking in the inky darkness, gateways to realms far beyond our conventional understanding. Another prominent voice in this debate is Professor Ravi Nandakumar, whose research in quantum gravity has attracted international acclaim. He cautions that while these ideas are undeniably fascinating, they must be approached with rigorous scientific skepticism. To propose that black holes are portals to other universes is to step into the realm of theoretical physics, where the line between imaginative speculation and empirical science can blur. There are many mathematical models that permit such phenomena, yet we remain deeply aware of the enormous technical and observational challenges involved in validating these models. The interplay between quantum mechanics and general relativity in these extreme conditions is still an open frontier. Dr. Nandakumar further elaborates on the potential mechanisms at play. One hypothesis is that the singularity at the heart of a black hole might not be a true point of infinite density, but rather a transitional phase, a bridge, if you will, to another region of space-time. In these models, the event horizon is not an absolute border, but a kind of membrane where the familiar laws of physics start bending, twisting, and ultimately breaking down. It is precisely this breakdown that invites speculation about what might lie beyond. Complementing these serious scientific discussions, a younger scientist, Dr. Lila Zheng, brings a fresh perspective to the table. With a background in both astrophysics and theoretical cosmology, Dr. Zheng is known for her passionate advocacy of the multiverse theory. When we talk about black holes as potential portals, she notes, we are really asking whether these phenomena provide us with a glimpse of a larger, far more intricate cosmos. One where our universe is just one bubble among countless others, each with its own distinct laws and histories. It's a thrilling concept that challenges every intuition we have about the nature of reality. The expert community also acknowledges that these theories, while captivating, are not free from controversy. Many researchers point out that the extreme conditions inside a black hole, where space-time is twisted beyond recognition and quantum fluctuations reign supreme, present formidable obstacles to our observations. The lack of direct observational data makes it incredibly difficult to test these hypotheses, Dr. Hawthorne admits. We are, in many respects, relying on indirect evidence and sophisticated computer simulations to probe realms that are well beyond our immediate reach. Yet, it is precisely this challenge that excites the scientific mind. Every year, new discoveries, be it in the form of gravitational wave detections or more refined imaging of event horizons, push the boundaries of what we know. As instruments become more advanced and our theoretical frameworks more robust, the tantalizing possibility that black holes might act as gateways to other universes gains a foothold in the imaginations of researchers worldwide. The scientific dialogue is evolving, spurred on by a passion for understanding not just the mechanics of these phenomena, but the far-reaching implications they might hold for the entire cosmos. One of the most provocative ideas involves the relationship between entanglement and space-time itself. A number of experts are investigating whether the puzzling phenomenon of quantum entanglement, where two particles remain mysteriously linked, regardless of the distance separating them, could be the key to unlocking a deeper connection between our universe and those that lie beyond. In many ways, Dr. Zheng explains, entanglement hints at an underlying web that connects disparate points in space-time. If we can harness this intuition, even in a theoretical sense, It opens the door to the possibility that black holes could be intertwined with alternate universes in ways that we are only beginning to conceptualize. In dedicated research centers located at the cutting edge of astrophysics, interdisciplinary teams are melding data from cosmic observatories with advanced numerical models. Their goal is to simulate the violent, chaotic processes taking place at the heart of a black hole, and to see if these models can be extended into the realm of speculative theory. In laboratories where supercomputers hum in unison, researchers run complex simulations that track the evolution of space-time under conditions that have no counterpart in our everyday experience. Although experiments remain largely confined to the realm of theory and simulation, the insights gained from these efforts have profound implications. They inform our understanding of everything from the behavior of cosmic rays in deep space to the potential for quantum computing, to unlock new realms of discovery. Each new piece of data serves as a stepping stone towards a more integrated picture of a universe that is both awe-inspiring and fundamentally mysterious. The voices of these experts resonate with a common theme, a profound humility before the vastness of the unknown. Their collective research and shared insights remind us that the quest to understand black holes is as much about asking the right questions as it is about finding definitive answers. The discussion is far from over. As our instruments become more refined and our theories more daring, the possibility that black holes are not endpoints but gateways continues to ignite debate and inspire future research. As you listen to these expert insights, imagine the thrill of standing at the precipice of understanding, a place where each new discovery is both a revelation and a deeper invitation into the cosmic mystery. The interplay between rigorous science and speculative wonder elevates our curiosity, compelling us to explore boldly and to confront the deepest enigmas of the universe. These are not mere academic musings. They are the stepping stones that lead us to consider that perhaps, in the heart of every black hole, there lies a silent promise of discovery, a doorway to realms that lie beyond our immediate perception. As our experts continue to share their perspectives, we begin to see the contours of a theory that is as rich in possibility as it is in scientific rigor. Their passion and curiosity serve as a beacon for all those who dare to look beyond the familiar, daring to ask the question, could these mysterious cosmic entities be more than the end of a journey, but the beginning of an even greater one? As we venture further into the speculative realm, the question of whether black holes could serve as portals to other universes takes on an even more intoxicating allure. This segment invites you to suspend your disbelief and to consider the universe not as a static expanse, but as an ever-changing tapestry of interconnected possibilities, a place where the boundaries between known physics and imaginative theory begin to blur. At the heart of this speculation lies the idea of wormholes, theoretical passages through the fabric of space-time that could, in principle, connect distant regions of our universe or even lead to entirely separate universes. The concept is not new. Studied extensively since the early days of general relativity, wormholes have become a staple of science fiction and theoretical physics alike. Yet, the possibility that they could be realized within the confines of a black hole's extreme gravitational niche offers a tantalizing narrative twist. The mathematics behind wormholes suggest that they require the existence of exotic matter, a substance with negative energy density capable of stabilizing these cosmic passages. While such matter has not been observed directly, certain quantum phenomena hint at its possible existence on very small scales. Some physicists propose that evaporating black holes, through processes such as Hawking radiation, might create pockets of negative energy that enable, however fleetingly, the opening of a wormhole. If this is so, then black holes might momentarily act as cosmic doorways, offering glimpses into adjacent realms. Consider for a moment the possibility that what we perceive as a black hole's singularity is not the terminus of matter and energy, but rather a bridge, a two-way conduit to another universe. In such models, the collapse of a massive star could give birth not only to a black hole in our universe, but also to a nascent universe on the other side of the event horizon. In this speculative framework, each black hole might be the seed of a whole new cosmos, each with its own unique properties and physical laws. The picture that emerges is one of cosmic fecundity, a universe that is in a constant state of regeneration and evolution. This idea resonates with some of the most revolutionary concepts in modern cosmology, such as the multiverse theory. The multiverse posits that our universe is only one of an enormous ensemble of universes, each potentially governed by different sets of physical constants and laws. If black holes can indeed channel matter and energy into separate realms, they might be the conduits through which universes are continually birthed, interconnected by ephemeral passages hidden within the dark recesses of their event horizons. The speculative analysis does not stop at pure theory. It is informed by the latest computer simulations and mathematical models that explore these extreme conditions. Researchers have constructed scenarios in which the collapse of matter into a black hole induces fluctuations in space-time that momentarily open up tunnels. These simulations are based on known principles of physics, but also incorporate innovative ideas from quantum gravity and string theory. In these models, the borders between space and time dissolve, offering a glimpse into a reality where the concept of before and after blurs into a continuum of possibility. And what of the observer, the intrepid soul who dares to peer into the heart of a black hole? Some theories suggest that for an object plunging into a black hole, time itself might slow down to a standstill. Yet, in the speculative scenario of a portal, this experience might transform into a journey, a passage between one state of existence and another. It is a narrative that mirrors the hero's journey, the descent into darkness, replete with trials and the transformation that emerges from having touched the unknown. As we contemplate these ideas, it is important to recognize the delicate interplay between rigorous science and the fertile realm of hypothesis. There is a fine line between what can be demonstrated through observational evidence and what remains a captivating possibility. And yet, it is this very line that fuels our curiosity. Every anomaly in the data, every unexplained gravitational ripple, hints at the possibility that the universe is far more expansive and mysterious than our current theories suggest. Consider the case of supermassive black holes, which reside at the centers of galaxies, including our own Milky Way. Their immense gravitational presence shapes the destiny of entire star systems, yet their internal workings remain obscured by a veil of mystery. Some speculative models propose that the intense gravitation at these centers could create conditions ripe for the formation of quantum tunnels. These tunnels, transient as they might be, raise profound questions. Are they mere curiosities of mathematical theory, or could they represent real bridges between disparate cosmic realms? It is in this intersection of proven science and imaginative extension that the theory of black holes as portals finds its most compelling narrative. The implications of such a phenomenon, if ever substantiated, would be profound. Not only would it revolutionize our understanding of gravity and space-time, but it would also reframe our conception of the universe as an interconnected web of realities, each pulsating with its own life and hidden potential. In urban legends and the annals of science fiction, black holes have long been depicted as mysterious wormholes, secret shortcuts through the cosmic expanse. Now, With every advancement in high-energy astrophysics and quantum field theory, these legends seem to take on a sheen of scientific plausibility. There is an almost poetic irony in the idea that the very force that appears to obliterate light and information might also be the architect of new beginning, a cosmic regeneration engine that continuously spawns universes, each a mirror and a mystery. As we march deeper into these speculative territories, we are forced to grapple with the ultimate questions of existence. Is our universe unique, or merely one chapter in an eternal saga unfolding across an infinite multiverse? Do the laws of physics, as immutable as they seem, simply represent a local template, while other realms dance to entirely different rhythms? And if black holes serve as the crucibles of new creation, a cosmic reproduction process, what might we learn about our own origins, our place in this vast interconnected system? The speculative landscape is as vast as the cosmos itself, and each theory invites us to dream bigger, to question further, and to recognize that the boundaries of science are always expanding. Although many of these ideas remain on the fringe of conventional acceptance, they are an essential part of the dialogue, a dialogue that challenges us to think beyond the obvious and to embrace the wonder of the unknown. As you listen to these exhilarating possibilities, consider that the journey into the heart of a black hole may not culminate in an insurmountable barrier, but might instead mark the beginning of another odyssey, a journey into a universe that parallels our own in its beauty and mystery, yet diverges from every law we hold dear. Such ideas transform black holes from symbols of ultimate destruction into beacons of cosmic rebirth, suggesting that every ending is, perhaps, only the precursor to a new beginning. In our quest to understand these cosmic marvels, one thing remains clear. The boundary between scientific fact and dreamy speculation is ever shifting. With every new observation, every nuance captured by our telescopes, we are reminded that the universe is an endless repository of secrets, waiting for the brave minds willing to decipher its coded messages. And who knows? In the not-too-distant future, what now seems like speculative fancy might be recognized as one of the most revolutionary discoveries in the history of cosmology. The narrative of black holes as cosmic gateways invites us to reimagine the very nature of reality. It challenges us to consider that the cosmos might be a labyrinth of interconnected passages, each joined capable of ushering in new realms of possibility. As we step back from the edge of speculative theory, the lingering question remains: could these enigmatic giants be the keys to a vast, unseen network of universes, each a universe unto itself, waiting to be discovered by those bold enough to explore the cosmic dark? As we reflect on the journey we have undertaken, it becomes clear that the essence of our exploration is not found in a single answer, but in the dialogue between what we know and what we yearn to discover. The possible role of black holes as gateways to alternate universes is a hypothesis that sits at the confluence of two realms: the established rigor of astrophysics and the boundless creativity of theoretical exploration. In many ways, this conversation is emblematic of the broader scientific process, a relentless pursuit to push the boundaries of knowledge, driven by both empirical evidence and an innate desire to comprehend the incomprehensible. Each new discovery acts as a catalyst for fresh questions. When we observe the subtle dance of matter around black holes, the faint reverberations of gravitational waves, or the enigmatic glow of relativistic jets, we are reminded that the universe is a living mystery, ever unfolding. The dynamism of cosmic phenomena teaches us that each answer is transient, a spark in an ever-growing flame of inquiry. Technological advances, such as high-definition telescopes, Gravitational wave detectors and sophisticated supercomputers are continuously refining our picture of the cosmos. Yet, as our instruments become sharper, the complexity of the cosmic theater deepens. This evolution of understanding is a testament to the intricate weave of scientific discovery. Every new datum reshuffles the deck of our cosmic theories, inviting us to re-examine our assumptions and dare to ask even bolder questions. Consider the paradox of information loss in black holes, a problem that has persisted since the early days of black hole physics. The seemingly irreversible disappearance of information challenges the core tenets of quantum mechanics, compelling physicists to reconcile these conflicting paradigms. Some of the most daring proposals even suggest that information may somehow escape into other dimensions or regurgitate back into our universe through subtle quantum effects. Such ideas, radical as they may appear, drive the scientific community to envision a universe in which black holes are not merely cosmic endpoints, but dynamic junctions in an elaborate, multi-dimensional network. As you continue to ponder the nature of these celestial phenomena, recall that the universe is far too vast and varied for any single theory to capture its full complexity. The interplay between gravity and quantum mechanics, the enigmatic allure of the singularity, and the possibility that every black hole is a gateway to another realm. All these notions invite an eternal dance between fact and possibility. In this spirit, our exploration today stands as both a celebration of human curiosity and a call to action for continued investigation. The story of black holes is one of transformation, where the death of a star might herald the birth of a new universe, where collapse and creation are two sides of the same cosmic coin. By challenging our preconceptions and daring to peer beyond the veil of the known, we continue an intellectual tradition that stretches back to the earliest stargazers. The dialogue between experts, the interplay of rigorous experimentation, and the whisperings of speculative theory form a mosaic as rich and intricate as the universe itself. Far from providing definitive answers, our journey through the mysteries of black holes underscores a powerful truth. Every ending in the cosmos could very well be the spark for a new beginning. So, let this extended reflection serve as an invitation to remain inquisitive, to celebrate the beauty of unanswered questions, and to join a community of explorers who, united by the common wonder of the cosmos, endeavor to unlock the secrets that the universe so coyly guards. The narrative is not complete with our understanding of today. It is a living story that continues to evolve and expand, much like the universe it seeks to describe. As the stars wheel overhead and the darkness of space envelopes us, remember that every glimmer of light is a reminder of the vast mysteries that remain. The possibility of black holes acting as portals to other universes might seem like a tantalizing dream, but it is a dream grounded in the relentless pursuit of truth, a pursuit that transforms every inquiry into a leap of faith, every observation into a step toward the unimaginable. In the quiet, reflective moments after our cosmic odyssey, let your mind wander amid the infinite expanses. Consider that, whether through chance or cosmic design, every black hole might be an invitation, a threshold to a universe of infinite potential, waiting for inquisitive minds to step through and explore its uncharted territory. Thank you for joining us on this expansive journey across the boundaries of science and imagination. Our exploration is far from over, and the mysteries of the cosmos remain an eternal invitation to dream, explore, and seek out the wonders that lie just beyond the horizon of the known.
In the quiet recesses of the cosmos, far beyond the reach of our everyday perceptions, lies a realm of phenomena that challenged the human mind from the very first glance at the starry night. For millennia, humankind has looked upward, pondering the meaning of the flickering lights that speckle the vast void, questioning how a universe defined by laws so precise could also harbor realms of chaotic splendor and impenetrable darkness. The concept of black holes is emblematic of this paradox. On one hand, they are governed by mathematics so elegant that they could be described as masterpieces of natural design. On the other, they cloak the secrets of existence in layers of mystery that defy straightforward explanation. Over recent decades, scientists have devoted endless hours to piecing together this cosmic puzzle, deploying advanced telescopes, detailed simulations, and even space-based observatories to capture the elusive whispers of these gravitational titans. Observational breakthroughs have revealed that black holes are not isolated anomalies. They influence their surroundings in remarkable ways, distorting the orbits of nearby stars, igniting brilliant jets of radiation that pierce the interstellar medium, and, in some cases, even merging with other black holes to send gravitational waves rippling across the cosmos. Each observation adds a delicate brushstroke to the colossal canvas that is our ever-evolving understanding of these phenomena. Beyond the reach of current observational technology, the theoretical models propose the existence of several exotic phenomena. Some physicists suggest that inside the core of a black hole, where classical physics shatters into an array of quantum uncertainties, space-time itself might fold into configurations that allow for unexpected bridges between different regions. Picture, if you will, a labyrinth within the labyrinth, a series of interconnected dimensions where conventional laws are rewritten and the notion of singularity dissolves into a network of interwoven pathways. These ideas compel us to consider that the fabric of our universe is far more complex than a single, linear narrative. It may very well be a multi-dimensional tapestry, with black holes serving not as endpoints, but as junctions between diverging cosmic threads. Modern theories, including those in string theory and loop quantum gravity, explore the possibility that space itself is made up of tiny vibrating loops or strings, each a miniature dimension that, when viewed from afar, gives rise to the phenomena we observe in the macroscopic world. Imagine a scenario where the collapse of a star not only signals an end, but simultaneously initiates a new beginning in a parallel realm. In this view, the dramatic moment of a supernova might be the spark that ignites a chain of events leading to the formation of a new universe. Within its heart, the black hole could act as a transitional bridge, guiding the remnants of collapsing matter into a nascent realm where the familiar rules of existence take on new forms. It is this dance between creation and destruction that echoes throughout the cosmic narrative. The very processes that seem to conclude one chapter of a star's life may also be the precursor to the birth of something entirely novel, a universe where the known laws of physics are elaborated upon in unexpected ways. As we attempt to reconcile these ideas with empirical evidence, we enter a zone of perpetual wonder and intellectual challenge. Scientists often draw analogies between the structure of black holes and that of metaphysical gateways in mythology. The idea is not to conflate scientific theory with folklore, but rather to appreciate that both human imagination and advanced mathematics can converge upon the same archetypal motif: the threshold, the portal, the liminal space between one state of being and another. With each passing decade, as our instruments become ever more sophisticated, we begin to peel back the layers of abstraction that have long obscured the inner workings of black holes. Telescopic arrays, capable of harvesting light that has traversed billions of light years, buttress the theories that hint at black holes' dual nature. They reveal, in subtle whispers of radiation and gravitational undulations, an underlying complexity that beckons further inquiry. Even as we stand at the frontier of this research, challenges abound. The extreme conditions near a black hole force us to confront scenarios where everyday intuitions fail. Time, for instance, ceases to behave in a linear fashion. It can stretch, compress, and even loop back on itself, creating landscapes where cause and effect intermingle in perplexing ways. It is in these moments that the possibilities for alternate realities become most tantalizing, as the very boundaries that separate one realm from another begin to blur. This extended exploration invites you to share in the wonder of these possibilities. The more we learn about black holes, the more we realize how much remains shrouded in mystery. Every observation, every experiment, and every theoretical model builds upon an intricate edifice of cosmic understanding, one that is as mutable as the stars are eternal. As you contemplate the vast, intertwined narratives of cosmic creation and destruction, let your thoughts wander through this endless maze of possibility. The universe, in all its grandeur and enigma, stands as a testament to the unyielding quest for knowledge, a quest that, like a black hole, draws us inexorably toward the unknown. In the end, the exploration of black holes is not just a study of distant phenomena, but a journey into the very heart of our curiosity. It challenges us to reframe the way we perceive our place in the cosmos and to consider that perhaps every dark void holds the promise of new light, a promise waiting to be fulfilled as we continue to search for the hidden doorways to other universes. Let the mystery of the black hole serve as an enduring symbol of our quest for understanding, a symbol of how the most profound questions often lie at the intersection of science and the imagination. The deep, reverberating call of the cosmos is a call to explore, to wonder, and to dream of worlds beyond our own, where every ending is but a doorway to another boundless beginning. As this extended reflection draws to a close, allow yourself to be inspired by the vastness of possibility. The enigmatic allure of black holes beckons us onward, inviting us to pierce the veil of the unknown and to embrace the adventure that lies at the very boundaries of what we consider real. For in the cosmos, as in our hearts, the pursuit of truth is a journey without end, one that is as infinite and awe-inspiring as the stars themselves. In our continued exploration of these cosmic mysteries, every new insight, every stirring hypothesis, and every debated theory contributes to an ever-expanding mosaic that not only charts the structure of the universe, but also reflects the unquenchable human spirit. So, let us celebrate this journey, a journey through time, space, and possibility, and remain ever vigilant as we follow the dim, persistent light that guides us through the cosmic night.
Now that we have established the basics of black holes, let's venture into more speculative territory, the idea of wormholes and the multiverse. The concept of wormholes emerged from Einstein's equations and suggests that space-time might be connected in ways that allow shortcuts between distant regions of the cosmos. Wormholes, sometimes referred to as Einstein-Rosen bridges, are hypothetical tunnels in the fabric of space-time. If one side of a wormhole is near a black hole, it raises a tantalizing possibility. Could these cosmic tunnels serve as gateways to entirely new universes or different regions of our own universe? The answer remains uncertain. While wormholes remain a theoretical curiosity at this point, they fuel our imagination and underscore a broader speculation, the multiverse theory. This hypothesis suggests that our universe might be just one among many, perhaps with different physical laws and constants. In this light, black holes could be the portals into alternate universes, connecting disparate and unseen worlds. One of the key elements in our discussion is the event horizon, the boundary of a black hole beyond which events cannot affect an outside observer. From a distant perspective, anything approaching a black hole appears to slow down, almost freezing at the event horizon due to the extreme warping of space-time. This phenomenon is influenced by the powerful gravitational pull and exemplifies the bizarre behaviors predicted by general relativity. In simple terms, imagine watching a car approach a tunnel where the laws of physics begin to break down. As the car gets closer to the tunnel's entrance, it appears to slow down before vanishing from view. In the case of black holes, the disappearing act is not just an illusion, but a fundamental consequence of how gravity warps time and space. At the very core of a black hole lies the singularity. Here, all the mass of the black hole is concentrated into an infinitely small point, where density and gravity become overwhelmingly intense. This concept is not only hard to picture, it defies our everyday experience of the world, but it also signals the breakdown of our conventional understanding of physics. Scientists struggle to reconcile the behavior of matter and energy at the singularity with the rest of the universe. The laws that govern our cosmos, like Newtonian physics and even general relativity, no longer apply in their usual form. This has inspired efforts to develop a theory of quantum gravity, which aims to unite the principles of quantum mechanics with Einstein's theory of general relativity in extreme environments. The singularity represents nature's ultimate puzzle, a paradox where known physics ends and the unknown begins. As researchers continue to study black holes using mathematical models, computer simulations, and observational data from telescopes and satellites, we steadily inch closer to an understanding of these cosmic conundrums. Now, merging our understanding of black holes with the speculative allure of wormholes, we arrive at the exciting hypothesis: black holes as portals to other universes. This idea has been a mainstay of science fiction for decades, but some theoretical frames lend a scientific basis to the possibility. More precisely, if wormholes can exist, then perhaps certain configurations of black holes might enable connectivity between different realms of space, time, or even separate universes. Picture a labyrinth of interconnected tunnels beneath reality's surface. When an object falls into a black hole, it might enter a wormhole, a tunnel that bridges our universe with another distant or alternate reality. Although this remains speculative, the tantalizing possibility suggests that black holes could serve as cosmic gateways, transporting matter and energy to another universe or a very far-off region of our own. This concept not only fuels our science fiction fantasies but also leads to profound questions about the fundamental nature of the cosmos. If black holes are indeed gateways, then every event horizon might be a doorway to a world where different physical laws apply, and where entirely new forms of reality await discovery. Despite its appeal, the idea that black holes are portals is riddled with challenges. Foremost among these is the observational limitations imposed by the event horizon. Since nothing can escape from within this boundary, obtaining data directly from inside a black hole is impossible with current technology and scientific methodologies. Moreover, the extreme conditions near a singularity make it exceptionally difficult to simulate or replicate the environment using laboratory experiments. For now, our understanding of black holes relies heavily on indirect observations, sophisticated computer simulations, and theoretical physics. Sensitive instruments like the Event Horizon Telescope have recently provided us with our first-ever images of the regions around black holes, offering a glimpse into these mysterious celestial objects. The challenge, then, is to reconcile our mathematical models with the observable universe. While the equations support the possibility of wormholes and alternative universes, direct evidence remains elusive. This gap between theory and observation drives scientists to continue exploring, pushing the boundaries of knowledge as they venture ever deeper into the cosmic unknown. The idea of black holes as gateways to other universes has long been a fertile ground for science fiction writers, filmmakers, and storytellers. Movies like Interstellar have brought concepts like wormholes and event horizons into popular culture, sparking the imagination of millions around the world. The allure of traveling to unknown worlds, coupled with the mystery of black holes, makes it an irresistible topic for creative exploration. However, it's important to distinguish between imaginative fiction and the rigorous scientific study behind these phenomena. While science fiction thrives on extrapolation and creative liberties, researchers in astrophysics must rely on observable data and well-tested theories. That said, the interplay between the two has often served as a bridge, inspiring young scientists to explore these cosmic puzzles and fueling public interest in fundamental research.
Our exploration of black holes, a journey that began with a suspenseful hook and meandered through the realms of established science, expert insights, and speculative analysis, leaves us with a profound sense of wonder and an invitation to keep questioning. The narrative of black holes as portals to other universes is as much about the limitations of our current knowledge as it is about the boundless potential of future discovery. As you reflect on what you have experienced in this documentary, remember that the cosmos is ever-changing, continually challenging the boundaries of what we conceive as reality. The enigmatic dark voids in the fabric of space may hide not just destructive power, but also the promise of renewal, a promise that every question leads to further discovery. Every mystery opens the door to deeper inquiry. We hope this journey has ignited in you an insatiable curiosity about our universe and a desire to explore beyond the limits of conventional understanding. Through rigorous science and daring speculation alike, the quest to unlock the secrets of the cosmos is an adventure that never truly ends. Thank you for joining us on this expedition into the heart of darkness and the edge of possibility. As you venture forth in your own explorations, whether in the realm of science, philosophy, or pure imagination, remember that every discovery is just another step in an endless journey.
As we emerge from the swirling vortex of theory, speculation, and cutting-edge science, we are left with more questions than answers, a hallmark of any great scientific journey. Black holes, with their uncanny ability to warp space and time, continue to captivate our imaginations and challenge our most cherished notions about the universe. Whether they are the final resting places of matter or the secret portals to other realms, their true nature remains one of the most enthralling mysteries of modern astrophysics. Today, we have journeyed together from the heart-stopping edge of the abyss into the intricate dance of gravitational physics, from the measured insights of leading experts to the bold, speculative visions of parallel universes. We have seen that the science behind black holes is as rigorous as it is fascinating, and that every new discovery opens up corridors of possibility that extend far beyond the confines of our current understanding. In the scientific discourse, black holes compel us to balance the precision of established theory with the unbridled creativity of speculative thought. Their swirling darkness is a canvas upon which the universe paints its most daring hypotheses, a reminder that, even in the depths of seeming oblivion, there might lie unseen doorways to realms more wondrous than we ever dared to imagine. While today's exploration has only scratched the surface, it leaves us with a renewed sense of curiosity. The possibility that black holes might serve as portals to alternate universes challenges us, not only to refine our scientific tools and methods, but also to ask, what lies behind that final veil of darkness? Could our universe be just one among endless cosmic layers, each waiting for a visionary to decode its secrets? As we close this chapter on our cosmic odyssey, take a moment to reflect on the vastness and the mystery that frames our existence. The journey of discovery is never-ending, much like the universe itself. Each question we ask propels us further into the unknown, where every answer is but a precursor to a new mystery. Now, as our documentary draws to a close, we invite you to join this journey of perpetual inquiry. Share your thoughts and theories. Do you believe that black holes might be gateways to other universes? The cosmos is as much a realm of scientific endeavor as it is a canvas for our dreams. Let us continue to explore, to question, and to celebrate the wonder that is the universe. Thank you for watching this exploration into one of the universe's most enigmatic phenomena. If you enjoyed this cosmic journey, please be sure to subscribe to our channel for more deep dives into the mysteries of space and science. We encourage you to leave your own theories and join the conversation in the comments below. The universe is full of secrets, and together we may one day unlock them all. As our final words echo into the infinite void, remember, every black hole, every story of cosmic wonder, is but a thread in the tapestry of existence. The mystery of the cosmos beckons, urging us to look beyond the ordinary into realms where science and imagination converge. Until next time, keep your eyes on the stars and let curiosity guide your journey. This is not the end, but a new beginning. And so, beneath the silent expanse of the night sky, where every twinkle is a beacon of mystery, the adventure continues. Our quest for knowledge echoes out into the dark, an invitation for all who dare to dream that the universe might be far more interconnected and mysterious than we ever dared to imagine. Stay curious, stay brave, and keep exploring the cosmic unknown. As we conclude this documentary on the enigmatic nature of black holes, we invite you to share your thoughts and ideas. Do you believe that black holes are the final chapter of matter and energy, or could they indeed be gateways to alternate universes? We want to hear from you. Please subscribe to our channel for more in-depth explorations into the mysteries of space and science. Share your theories in the comments below, and join a thriving community that is as passionate about unraveling the secrets of the cosmos as you are. Every comment, every idea, fuels the dialogue and pushes the boundaries of our collective understanding. Until next time, keep your eyes on the distant stars, and let your curiosity traverse the endless expanses. The universe is vast, and its secrets are waiting to be uncovered, one discovery at a time.